All right, in this video, we're going to review an example where we're trying to find defective light bulb, or at least one defective light bulb. So we're assuming that we know that in a lot of 20 bulbs, we know that there are 2 that are defective. So an inspector now wants to examine 5 light bulbs, okay? Because examining all 20 maybe would take too long. So we want to find the probability that the inspector is going to find at least one that is defective, okay? So in the lot of 20, he's going to pick out 5. And I want to know what's a probability that at least one is defective. Now, whenever you see at least one, that means that we want 1 to be defective, we want 2, we want 3, 4, or 5 that are defective, okay? What is the total sample space? Total sample space would be that 0 are defective, 1, 2, 3, 4, or 5 are defective, okay? And this is what we want to know. So figuring out the probability that 1, 2, 3, 4, 5 is that's a lot to try to figure out. It's always easier, or most of the time, it's going to be easier whenever you see at least one to start thinking about the complement. What is the complement? The complement is 0, right? So the what is not at least one? Not at least one is 0. 0 are defective. So if I were to solve this using complements, which you do want to do in this case, we would do 1 minus, because remember, total probability is 1. So 1 minus the probability that none are defective. So that means 5 out of 5 of the ones that the inspector chooses are not defective. Okay, so equals 1 minus. Now, what is the probability of him choosing, or he or she choosing 5 non-defective light bulbs? Okay, so let's think this through. So we are, in the numerator, we are choosing 5. 5 out of how many? How many of them are not defective? Well, there's 20 light bulbs. 2 are defective. So that means 18 are not defective. 18 are not defective. And we want to choose 5 of those 18, basically. How many ways can we choose 5 of those 18? Well, let's think this through. Is this how many ways? So let's see, are we going to be using permutations or combinations? Because we're basically selecting from these 18 without replacement, right? The order that we select them doesn't matter, right? Because remember, position or order matters for permutations. For combinations, it does not. Right? And of course, no, it doesn't matter if you get the defective one first, or the not defective one first, right? The order that you're selecting those bulbs doesn't matter. It just matters whether or not at least one of them is defective. So order does not matter. So that means you would have 18. You're going to be using a combination. 18, choose 5. All right, and the total number of ways that you can choose a light bulb from those 20 is, you have those 20 light bulbs and you are choosing 5. All right. Okay, so then what do we have here? 1 minus this. How do we calculate this this probability here? Right. You could use your formula for combination. Right. If you remember that is n choose k equals n factorial, k factorial, n minus k factorial. Right, you could use this, or you could use a calculator, right? Most of us have Excel on our computer, so Excel is always my favorite way to do these type of calculations. So we would say, okay, equals combine, all right? In the numerator, I have 18, and I am choosing 5. And in the denominator, I have combine. That's the combination formula in Excel. And I have 20, and I am choosing 5. Close that parenthesis and press enter, and you get 0.55. Okay, so this is 1 minus 0.55. All right, now I can go back to Excel and do this calculation. I can actually just double click on this formula and then do 1 minus in front of it. Press enter, 0.4, if I round that, it'll be 0.45. 0.45. Okay, so it's a pretty good chance that this inspector is going to find a defective light bulb, right? He has a 45% chance of finding at least one defective. Okay, now stepping this up, making a slightly more difficult problem, how many bulbs should the inspector examine so that the probability of finding at least one defective light bulb is at least 50%? So now I want, the probability of at least one defective, okay, I want this to be greater than or equal to half, right, or 0.5, because it needs to be at least 50%. Right, and I don't know how many I'm going to be sampling. So before I was sampling 5, right? Now I don't know how many I'm going to sample. So I can use the exact same formula. So I have 1 minus 18. So this is still, I'm using the complement. So actually let me go and write that. That is 1 minus the probability of none defective, greater than or equal to 1/2. So 1 minus, okay, and then none defective. So I have 18 that are not defective, and I don't know how many I'm choosing, right? That's what I want to calculate. How many should the inspector examine? So 18, choose X, over 20, choose X. Okay, so we're not choosing 5 now, we're choosing an unknown amount. And this needs to be greater than or equal to 1/2. So now it's just a matter of solving this algebraic expression or equation. So let's see, we would maybe first thing go ahead and subtract 1 from both sides, or actually, I'll add this piece here to both sides. Well, yeah, if I subtract 1 to both sides, then I'm going to have a minus here on this side. So to make both sides positive, I'll just flip that sign. So this would be less than or equal to 1/2, right? Because 1/2 minus 1 is negative 1/2. And then I would flip the sign so that I'd have positives on both sides. Get rid of that minus there as well. Okay, so now let's see. I would need to go ahead now and use my formula for combinations. So I'm going to do that over here because I'm going to run out of room. So 18 choose X. What is that? That is 18 factorial divided by X factorial, 18 minus X factorial. That is straight up the formula for 18 choose X. All right, all that divided by 20 factorial, X factorial, 20 minus X factorial. This needs to be less than or equal to 1/2, right? And since I have a fraction on a fraction, let me simplify that by multiplying it by its reciprocal. 18 minus X factorial times X factorial, 20 minus X factorial divided by 20 factorial, less than or equal to 1/2. Let's see, we have some cancellations here. This guy cancels with this guy. All right, so we have a little more cancellation because we know we can take this 18 factorial and then we have this 20 factorial. So what is 20 factorial? 20 factorial is basically 20 times 19 times 18 and times 17, etc. So basically that is 18 factorial there. So this guy will cancel with that guy, right? And then also we have a little more cancellation because we have 20 minus X factorial and then this 18 minus X factorial. So 20 minus X factorial, of course, let me write that down here because kind of running out of space. So 20 minus X factorial will be 20 minus X times 19 minus X times 18 minus X times 17 minus X, etc. So that would be basically factorial there. We still have this 18 minus X factorial here. Then we still have this 20 times 19. Okay, this guy here, let me use a different color. So he will cancel with this guy, right? And I'm left with 20 minus x, 19 minus x, and 20 times 19. 20 times 19. All right, so this is like kind of like a quadratic equation now. And I've run out of room once again, so let me see if I can move over a little bit more. So I'm going to take this up here. I can go ahead and FOIL, right? So 20 times 19 is 380 minus 20x minus 19x plus x squared. Okay, all that divided by 380 less than or equal to 1/2. Multiply both sides by 380 to get rid of your fraction. Also, 19 is what? That is 39x plus x squared. All right, so 380 times 1/2 is 190. Okay. Oops, I forgot the 0 there. So 380 minus 39x plus x squared. All right, subtract 190 from both sides. Minus 190, and I get 190 minus 39x plus x squared is less than or equal to 0. Okay, and then I need to basically solve for x, right? So I can use quadratic formula to do that. If I were to use a quadratic formula, I would get x is 33.29 and 5.7. Okay, so you can use the quadratic formula and show this. Okay, and of course x, basically remember, what is x? It's the number that we're asking the inspector to sample. So they can't sample half of a light bulb or 0.7 of a light bulb. And they can't sample 33 light bulbs because I only have 20. So that's not going to be a solution that we're going to use. And we can't sample part of a light bulb, so we're going to need to round that up and say, okay, inspector, we need you to inspect at least 6 light bulbs in order to find, in order for your probability to be greater than 50% of finding a defective light bulb. So you need to inspect at least 6 light bulbs would be our answer.